Hello everyone. So today we have lesson 5 of the bootcamp, of C# bootcamp, and as promised, share the slides before we start. I got really nice feedback last time, so I'll try to make the lesson slightly better. Way better than the last one, for sure. Let's wait 1 more minute till other people come, and we can start. I hope homework 4 was not too intimidating for everyone. The next one will be more interesting. Yeah, you'll get pizza after each lesson. Digital pizza. Oh, one more thing before we start. I need one person to track of questions. One person to track questions. So at the end of lesson, or when I ask, that person can paste all the questions that were asked. So any volunteer to track all the questions that have been asked. It would be really nice to have a volunteer. One moment. No one? No volunteers? To write, to keep track of the questions? The thing is, I won't be answering questions while I'm explaining other things, because it causes interruptions and other things. So I would appreciate if anyone could keep track of questions, all the relevant questions, not just random questions, maybe fix them grammatically, and then just post it. And then just post it. I'll ping mentors too. Mentor. Okay, just in case. So all you have to do is to copy a question that you notice, and at the end of lesson, I'll answer those questions. At the end of theory part, I'll answer those questions. That will be the main difference compared to other lessons. I will not pay too much attention in chat while doing a theory part, because it should be focused, I think. So Steka, if you could, I would appreciate. I agree that a mentor would be better, but I don't know if any mentors here. I think chat is needed at least, well, a background could be changed maybe, but I think chat is needed because people who watch on YouTube will not see a chat that you see on Twitch. So it's needed. But in this background, I agree that right now it doesn't make much sense. But this is for a future stream. I'll figure out a better placement for chat. I agree that it's not good. But anyways, we can start now. Thanks. So today we'll talk about loops and arrays. So the agenda is to talk about array, about new keyword, about null, about passing arrays, about for, while, do while, for each loops, how to skip an iteration, how to break an array, how to return from an array. We'll talk about nested loops, and we'll talk about how to initialize an array in an easier way with C#. And we'll also get a bit deeper into string, slightly deeper, a string in relation to array. So let's get to it. So array is used to store something of the same type, but something many times, multiples of something. And so in this example, you can see we have pears and apples. So 3 pears and 1 apple. We can store pears in pears array. An apple cannot be stored in pears array because it's of a different type. So instead of having 3 pears, we can have pears array. And when we create pears array, we will say how big is the pears array, and we can access an individual pair in it by index. So here you can see pairs. The first pair is pair 0. Indexes for arrays start at 0. Remember that. They don't start at 1, they start at 0. So next element is plus 1 to the index before. And in the picture on the left, you can see, again, first index is 0, and 9th element is actually at index 8. So those are points of interest. And the things that we can access array by are called indices to be precise. Right. So how do we create a new array? With arrays, before we start object-oriented programming and getting deeper into objects, this will be your first confrontation with null. Null is something that's undefined. For example, if you declare a private static int and don't give it a value, the value will be 0 by default. But if you do the same for an array, the value will be null. Null meaning it's undefined. So with null, you will start seeing null reference exception. Basically, one of the most common errors in programming. So brace yourself. And to fight null, there's only one remedy, is to use new keywords, so initialize stuff so that it's always there, and just avoid passing null altogether. So to create a new array, we say new, and then type, and then give it a count. And I'll give a demonstration of how it's done in code soon. So when we create a new array, we need to know how many elements we pass to it, or how many elements it can contain. So the only remedy against null and null reference exception is creating objects and not passing null around, just eliminating it if possible. So the most common errors with array are, as I mentioned, null reference exception, when you try to access something that doesn't exist. So you're trying to use something that is not yet initialized. Another one is when you, for example, have 5 elements in an array and you try to access 10th element. Well, array has 5 elements. How are you supposed to access 10th element? And then you'll get out of range exception. And lastly, overflow exception. If your array is too big, like way too big with billions of elements, you'll get something like this overflow exception. So here's how you create an array. Like I said, new, type, and size of array. And then you assign each element afterwards. So here I say I create a new array of 3 ints, and the first int is 1, second int is 10, third int is -5. When we create an array, like as mentioned before, we use a new keyword. And new keyword means that we create a new reference. And so when we pass around arrays, we actually pass around references. And so if we modify an array within a function, the changes persist. So if I change values of elements at array, for example, in this case, first, second, and third elements got set to zeros, then after the array leaves a function, those values have been changed as well. So the changes persisted in the original array. And so if I print this, which had values 1, 10, and -5 before, in the output after it goes to default values function, it will become 0, 0, 0. This is because I don't copy an array, I pass its reference. So it still links to the same array that was before. Primitives like int, bool, and others are passed by value, meaning which if I make a change, that change outside function for that value will not persist. So if you want to modify an array and see the results or take the results, you don't have to return it again. And that's a beginner mistake, that people return an array that they put as an input. You don't have to do that if you don't create a new array inside. Array, like tattoos, is immutable. So if you created an array with size 3, then you cannot add any more elements to it. You cannot remove elements from it. And I said it slightly wrong. Array itself is mutable. You can change values of individual elements in array, but you cannot change its size. So if you want to expand or shrink an array, you'll need to create a new one. And to see how many elements in an array, you can do with .length property. Every array has this property, .length, and it will say count of elements within an array. So what would we need to do if we wanted to add a new element in an array? We would need to create an array with one size bigger array, and copy all elements from the old array to the new array, and then assign the new element at the start, in the end, or some other place where it was supposed to be. So that's what you would do if you wanted to change size of array. And of course, we want to process arrays somehow, and the answer is how we process arrays is loop. Loop is something that happens many times, and it doesn't really have to work with array. It just means that it will happen multiple times. It will execute your code multiple times, the exact same code, unless you have conditions that tells it to do different things. So, since it's inconvenient to access elements in array one by one, it's really convenient to do that in a loop, or instead of repeating code, doing it in a loop multiple times. So a loop is used to not 100% correct. A loop is used to do something multiple times, and in context of array, it's used to iterate over array elements. So we have a bunch of loops, and the most simple one, the most common one too, kind of, is for loop. For loop has to have a start. So that's the start index usually. And then the second thing, it has a condition which tells when to stop. So I start at 0 and I stop when I reach the last element of array. And then in every iteration of array, I increment the index by 1. Plus plus means to increment by 1. So here, what I will do, I'll print every element in array, starting from 0 and all the way till the end. While loop is, so when do you use for loop? You use for loop when you are working with index of array. When index of array is important and when you know length of array, then you can work with a for loop. I said when you know length of an array, you don't have to know it yourself as long as you can determine the size, the length of it using dot length. While loop is another loop, less common. It's used to iterate through stuff. It's not used to iterate through stuff. It's used to do something until condition is true. So what happens in while loop? We check a condition. And while this condition is true, we do what's within the scope of the while loop. So in this case, we say sum, add 10 to sum until sum reaches 100. And this means that this sum plus 10 will be repeated 10 times till it reaches 100. So while loop is used when you don't have to work with an index. Basically, then while is better than for loop. Do while is very similar to while loop, except that when you want to repeat the loop at least once, regardless of the condition. So the code will work like this. You have sum, and then you do the addition once, and then it says, okay, sum is 10 now. 10 is not less than 0, and so it will stop. But it did execute once. And that's do while loop. And this is a perfect prime example of why while loop, do while loop is less popular than while loop, because you act first and then you check if you could have acted or not. And so it often results in errors, and that's why it's way less popular. With while you check beforehand, and with do while you check afterwards. So it's rare for this reason, but still has its place in programming. So the condition to terminate is in the end. For each is a type of loop when you want to loop through all the elements in a given collection. So the key parts here is that you need a collection, and then you say for each member in this collection, do something with this member. So for each number in array, I print it. Quite readable, quite intuitive, and quite common as well. So when you don't care about index, when you are reliant on a collection, on array, you want to print, you want to use a for each. So no index needed, and it's quite convenient to immediately take a member and use it, an element in array. There are three ways how to pause a loop, how to stop a loop, how to return from it. And one of those ways is already known, it's return statement. Since return statement simply exits a function, it exits a loop as well, along with the function. But there are two more. There's also a break statement, and it basically stops a loop and moves on. And then there is a continue statement, which skips current loop iteration. So here are the examples of three of those three stops, and the different impact it has for the same code. Here we have a function called infinity, and it's actually a bad name. It should be called probably something like power number. So what this function actually should do is take a number and multiply it times that there are that is defined by variable degrees, by parameter degrees. So what happens in this function? We say while true, and while true means always. It's never false. It will always run. So this means we multiply. Exponent is a better name. So we multiply a result by a number, and then we take away a degree, decremented by 1. And so we say if degree is less than 0, we stop, and in the end we return result. However, what happens is that if degree is less than 0, we don't stop, we just skip the iteration. So when degree becomes 0, we just keep on skipping iterations, and it actually doesn't mean anything. We just continue till infinity, and nothing happens. So this infinity 1 function will just be infinite and will never return the result. And so it might cause many problems, and it will cause many problems. Now, an actually reasonable version of this function would be a second version where we don't use continue, because it doesn't make sense. We don't want to skip an iteration. We want to break out of the loop when it makes sense. So when degrees, when we multiply it enough times, we want to stop multiplying and just return a result. So we break from a loop and return a result. And in third scenario, if degree is less than 0, we immediately return the result. And we could, of course, use the condition in the while loop, but my point was to illustrate those three stops and pauses. So the impact of it in the function. Of course, a more reasonable way would be just if degree is less than 0, to put that in the while statement. Way cleaner, way better. But this is to have a comparison. And now here are some tips and tricks of the loops and arrays. So stop early. If you can break from an array, if you can skip an iteration, if you can return a result, please do so as soon as you can. Those three things are your friends. So do validation as soon as you can and stop as soon as you can, because the more you wait, the later you put validation and the later you stop your array. If you have to stop it, if you have the choice, then the more likely you will leave an error behind, and the more likely you will introduce a bug in your application. So another tip is when we have a for loop with a nested for loop, or in general, nested loops. This is really hard to read because you need to track what row it is, and then you need to track what column it is and what it does with the column and row. And in this case, it doesn't do anything with column. It just prints row 10 times. So a way to force, to give our freedom, to give our brain freedom to not to think about a nested loop, just think about one loop, because one is plenty. We can have functions. So here we have a very simple one-dimensional loop, just one depth. And inside it, we actually have another one, but we don't care it because it's nicely hidden under a function. So when we have written it like this, it's really easy to understand what it does. It simply means that 10 times we do something with a row. So use functions to make it cleaner, easier to read. In C#, we have lots of syntactical sugar, and one of that syntactical sugar is object initializer. Array is an object, and so we can utilize such feature. Above, you can see how array would be initialized in most languages normally. You basically say how many elements it takes, and then you say that the first element, second element, third element is a specific value. But there is an alternative way of initializing an array when you know what elements it will have. So you can simply say array equals new, and then array brackets, square brackets, and then you just type the elements within those curly braces. 1, 2, 3. So the one above and the one below are equivalent, and the one below is called object initializer because we create a new object, a new array, and at the same time set its values. So it's extremely convenient when you know what elements are in an array. Next. Remember string? String is many characters, essentially. It's text. So text is made of many characters. And in many languages, string is actually an array of characters. But in C#, string is not an array of characters. It's an abstraction of it, meaning which it doesn't share the same semantics. For example, in the before example, I could modify elements at certain indexes and change their values, but for string I cannot. If I do that, and you'll see in the message below, it will say property or indexer string cannot be assigned to. It's read-only. That means that I cannot modify an existing string. I can only create a new one or set it to a new one. So when I do name equals Kaizenel, for example, I actually create a new string and assign it to the variable. So strings are immutable, and when you assign them, you actually create under the hood a new array of characters. But you don't treat it as characters, you treat it as its own thing, as string. And for this reason, if you assign a new string within a function, the change will not persist outside that function because you basically created a new array. And now let's go to coding. First, questions. Steka, could you paste some questions if there were any? I see there was a question about continue. So yes, if you have 5 continuous, well, okay, what continue does, it skips a single iteration of a loop. So if my loop hit continue once in 5 iterations, that means that it iterated over 4 times. If you don't pass a count, how many does it store? If I don't pass a count, it's invalid. So let's demonstrate something like this. I have an array of ints, and I initialize an array without a count. And here you go. Implicitly type array should have an initializer. So, int. And you see, array creation must have array size or array initializer. So it means I either have to do something like this, specify how many elements in array, how big is the array, or I can give it already a set of numbers that it contains. And this works because array, like var, is smart enough to know that this is only possible with int of 5. Yes, and I don't even need a type then. That's feature of C#. So it's really simple. Not as simple as JavaScript, but simple. Any more questions? Do you guys have any more questions? I have a main somewhere. I still have a main somewhere. Any more questions? Yeah, it's not as simple as Python and other languages, to be honest. Okay. Any more mains? Many mains. Okay. Why use so many times var, not int, string, etc.? So here's the thing about var. It took me some effort to just write int and then brackets, and with var it's just 3 symbols. What value do I get by writing int and then square brackets? It's already obvious that this is an array. Well, actually, I could just do this if I made it an int. And if it's a var, I have to do this. But anyways, the reason why I use var so often is because it's not necessary to define explicitly what type it is all the time. And it's more readable if you don't use a type in most cases. For now, for all the cases, to be honest, if you name properly, you don't really need to specify type explicitly. All right, I hope that answered the question. Empty array. Okay, sure. I wrote some remarks, so let's play around with it. If we have an empty array, so we have an empty array, what do you think happens when you try to do something like getting first element in empty array. What happens? Will this work? Why does the program crash? Maybe you can say what error it will be. Okay. So let's go to slides and specifically to this one. Oh shit. To this one. You're a kid who is trying to drink a milkshake, but the milkshake is out of your range. You're trying to reach an element from an array which is out of your reach. And so you would get index out of range exception because there is no variable there. Resho, what mentors say, we might have different opinions. So if you are confused or unsure if what they say is like good or you have different opinion, then you're always free to consult with others. Anyways, this throws a system out of range exception. Index out of range exception. So let's move this to a function. Any more questions? Oh, static void. Right, so how do we add a new element to array? So we have an array, and like the before, it's empty. I'll actually do this in the function, easier that way. Private static void, actually int, add element, element demo, no need int, void is enough. So let's add an element to an array. So, okay, we have an array with 0 items in it. And then what can we do to add a new item in the array? And the answer is we create a new one. With one item, and let's say it doesn't make sense in this case, a really poor demo. So we pass an array, and we want to expand it with a new item in the end. So int number to be added. So as mentioned before, what do? We first create a new array with size 1 bigger than the initial one. So size. So this means one size bigger than the initial one. And then we need to take all elements of the old array and copy them over to the new one. So I expand the array, copy elements over. So array 2, at this is array at this. And in the end, since I have, you know, this array had length this, and this array had length one more. So I have the last element still waiting to be loaded. So I can say this to be the number to be added. Is this clear? Yeah, append array, I'll call it. Append array is a good name. Do you have any questions from this? Yes, that is correct. What is it suggesting? Oh, right. There is this thingy, which I don't really use myself. It's a thing of C#, but if you want last index, you can use just this. This will mean it's last element of index, but I never remember that one, to be honest. So always use this as well. And since we created a new array, we need to return the results of a new array. So can we achieve array transfer with array copy to? Yes, we can. Array has this function, array copy to, which will basically do the same thing as here. So about this later, to be honest. I don't want you to learn those utility methods just yet. I want you to feel the pain. Roloff, what was your question? Let me know, retype if there was. Anyways, I'll continue. Let's demo this. So we create an empty array. Yes, I am. I'm very well known for being sadistic with my students. Can you not use add to add an item to the last place? No. It's not supported for array. It's only supported for a list, and we're not learning about lists yet. So no, you cannot just add an element with an add method. Your homework will be to implement that method yourself, so that you understand better how lists will work and why are they so useful. Okay. So append to array, new element, let's say 10. Out of range, append to demo out of range. Oops. Let's demo append to array. Private static void demo append to array. Let's move this one there. Let's call that one there. Okay, so what do? We demo append to array. So again, empty array. And the result is new array with one element, 10. So here is a pitfall that even people with like 1 year of experience can fall to. How do you print all elements in an array? And the answer is no, you don't print it by just passing an array to write line. What do you guys think what will happen if you pass an array to write line? Let's try it. You see what happens? It did not print the object values. It didn't print the object itself either. What it actually did, it printed the type, the underlying type that the object is. So never, ever, ever print objects like this if you didn't do anything extra for them. So for arrays, you'll need to do something like a for each. So if I want to print all the variables, all the numbers in an array, I'll have to do something like this. So number. I will not do a string interpolation yet. A whole topic about that later when we delve into string operations, most likely next lesson. System.int32 yes, console write sounds more reasonable. Expanded array. Expanded array. Append to array. We did not append it for some reason. Why did we not append it? So what happens? We created a new array with size one more than the previous one. We copied all the values over. We added the new value and it was supposed to be there. Why is it not there? Array is passed. Here we created an array, an empty array, and we passed it. And we append to array a number, and we expect it to be there. I'm using the wrong one. Yes, that's correct. I'm using the wrong array in the for each. Thanks. So if we run this now, we can see it printed 10 and then it printed the type. So when you want to print all elements, you need to do a for each loop. Don't print array object. Print array elements, and I'll actually write this above. Oops. Do not. Yeah, all good. Okay. So that's the pitfall that many people fall into. Right? Next. What happens if I define an array here without a value? Let's say array, and that's it. And then I say array. And like always, it says might not be initialized before accessing, so I cannot use it because it needs to be initialized. However, if I put it here as a static, I am able to access it. However, it says array is never assigned. So if I do this, nothing happens. But actually, if I do this, what will I get? What do you guys think? Will it be index out of range, or will it be something else? Yeah, it will be null reference. Reference. So I put it here, and I call it here, and let's witness the infamous null reference exception. Right, good job, good. Pass by reference. Let's witness the pass by reference as opposed to pass by value right now. So demo pass by value, by reference. So we have an array of numbers, and I don't need this. And what I want to do is to say to change all elements of array into whatever I pass as argument. So for example, set all elements to. So I get an array and I get a number. So what I want is to set all elements of array to be equal to that number. First, the question. Is there a way to run garbage collection so that we don't have a bunch of arrays, different sizes, with basically the same values taking up memory? The answer is don't worry about it. Definitely don't worry about it. Garbage collection is not your concern. And as soon as you as soon as your variable is null, as soon as it leaves a scope, as soon as it is no longer used. So for example, as soon as this function terminates, your variable will be garbage collected. Stuart Leslie asked, doesn't .NET Framework do garbage collection automatically? And the answer is yes. So you create arrays, expand them, and so ever. And when this function is done, all the memory that those local variables took is freed up. So the moment this function is done executing, you will have no memory consumption. So don't worry about it. Really don't worry about it. Whenever a variable leaves a scope where it's no longer referenced, it becomes garbage collected. So it's no problem. Set it fast. Steka, please know that question. I'll answer later. It's a bit off topic of this lesson, but I'll answer later. Set all elements of array 2. So what do? We do a for each. Element in array, and we say we cannot do a for each. Now, why can't I do a for each? Who can say why can't I do a for each? Yes, because we need the index. Well said. So, yeah. So I do it this way. The only actually, probably, I'm not sure, maybe a bad habit, but I kind of like calling index I because it's repeated many times, it's small scope, and it's kind of conventional in all places, so I don't mind calling it in a single letter. Anyways, what we want is to set all numbers to be in array to be the given number. So demo pass by reference, right? For each okay, so let's create an array. New int new 1, 2, 3, and let's print all elements. Number console write number. And lastly, we need to call it. So array is now this, right? Number. Let's say we want all elements to be 10. If I run this now, you see 10, 10, 10. Now, please tell me, what mistake did I make? What absolute redundant part did I make in this code? And why? Yes, so the redundant part is the function return. I don't need to return anything. So this part is not needed. I passed by reference, so my changes are persisting. So I don't need to set it to anything. So if I run this again, you can see the absolute same result. And so I'll say no need to return anything, changes persisted. All right, next. Let's play with strings, my last thing to do in agenda, I guess. It's probably wise to also demonstrate what happens. Well, that's the same thing, so it's okay. String demo. Why couldn't I use for each? A good question. Why couldn't I use for each? If I used for each, let's use for each actually. Can anyone explain why can't we use for each? For each. What if I just do this? What's wrong here? Can anyone explain? Yes. So with for each, we don't work on the array. We extract each element and work with each element as its own thing, as a copy of that element. So if we change this element to something else, and if it was a primitive, we won't have a change in the array. So you can see element is immutable. So we cannot change it. We cannot assign it to something new. So, good question. So this won't work because we work with copies of elements in array, not with the array itself. Next, string demo. So imagine if we have a string, let's say a name, and this name is non-capital. And a question. So it won't persist unless you open up the index instead of just changing the value. Exactly. It won't persist for exactly that reason. You work with copies of elements and not the element itself, and not the array itself. You need to work with the array in order to change its element's value. Okay, so string demo. We need to capitalize the first letter. So we take in a name, and we need to capitalize the first letter. What do we do? First thing could come to mind something like this, and you could just do this, right? And the answer is this won't work. And the answer is no, strings are not passed by reference. String is immutable, won't work. Oops. What do we do then? Any suggestions? Exactly. But let's continue with the suggestions. What if we do, as mentioned, string, replace, well, let's say we replace k with k. Whoops. So what happens now? We just replaced a string first letter with that one. First pass a name, and I print the name, and I print the name here. So before after, and in between. Oh crap. So what conclusion can we make from this? We actually see that we managed to capitalize name inside the function, but after we exit the function, the name remained to be the same, unmodified. What happened? And the answer is, what actually happened is that we did not change this first letter. We just replaced the whole string and created a new one. You see, it returns a new string. So it returns a new string. Every single thing that we do with string, it returns a new string. So the fix for this would be string and return name. But let's make this also properly. Of course, that is just a really stupid solution. So substring is a method to take pieces, to cut a letter out of string, to cut another string out of string, basically. So first letter. So we have first letter, which we capitalize. And what do we do then? We say name is, I cannot, string is immutable, remember? I cannot just do 0 equals to that. String is immutable. All those methods, you see substring from this instance, it's always creates that. Oh, for accessing, sure, I could. That's, yeah, more logical. But it's a character. You see, if I do this, it returns a character. So I need to convert it to string again. So it's roughly similar. All right, let's continue. So I take the first letter, I capitalize it, and now I need to take the remaining chunk of name. Yes. What have I done? My students violated by ASCII chart. So the name that actually should be is substring, starting from second symbol all the way specified length. So name dot length, length minus 2, because minus 1 would be the same length. Sorry, minus 1. Yeah. Yeah, that should do. So if I run again, make it void still, run again. Okay, as we can see, it capitalized correctly. And v1. Let's have two versions, shall we? So first version will print non-capital, and second version will print capital. So I basically copy pasted the functions and return the result instead of keeping it within the function. So if I run it again, you can see that it started with non-capital, in between it became capital, and then it was again non-capital, because I didn't really return the results. It's immutable, I need to return it. And in second case, I changed it again, but this time I returned it, so outside now you see that it printed what it should have printed. My name with capitalized first letter. So string is immutable, and passing it is passing a copy of it and not a reference to it. And that's why I cannot modify it inside. I need to return it. So keep that in mind. Some loops are slow. For example, just because it's a loop and just because you do one thing inside a loop, it doesn't mean that it's fast. So don't do something that's done here for obvious optimization reasons, because what this actually does, you see it's some unsorted random big array, and then 100 times you sort the array. Avoid this. There is no case where you would need to resort the collection 100 times, and if you do need to do that, you're doing it wrong and you need to reconsider your life choices, your algorithm. Due to optimization reasons, try to avoid running algorithms which within a loop, running complex algorithms within a loop. Ideally, what this should do, it should sort once and print the results, afterwards. So don't do mistakes, silly mistakes like this, because this is literally 100 times slower. This is literally 100 times slower. I should demo this for sure. Slow loop demo. Sort, I need to take sort as well. Don't mind sort, it's really unimportant. Imagine it's some imaginary sort function, doesn't matter much. But the key point is sort. Slow loop demo. Slow sort. Slow sorted numbers. So private static void slow sorted numbers print. Fast sorted numbers print. So we have 2 So don't sort inside a loop or do any other complex number. What do? We resolve it by putting outside the loop, so it's done once. Sort the loop outside of array and then print the results. Yeah. So, well, pretty obvious. I could put a stopwatch to measure execution time. Maybe I will. I will actually, for the hell of it. You don't have to memorize this. I'm just showing for measuring measuring time. So slow sort took stop. And again, start. And again, stop. And I should reset it. Okay. Fast sort took so wanna guess how long? Oh shit, I was supposed to print this in the new line. How long did the second one take? Any bets? Any guesses? It should take roughly 100 times more. Again, I'm still doing string demo, slow loop demo. Suboptimal loops comparison demo. Okay. So fast sort took 43. This one took 39, this one took 43, but I did it wrong. The reset stops time interval measurement and resets the elapsed time to 0. What the hell? I guess I don't do anything here of too significance. I do actually. Let's do a for and a for loop. That will mess it up more. Okay. So why is it printing such number? What the hell? Yeah, it makes a difference for large enough size. Unsorted array, we sort unsorted array. Oh, okay, right. So, I mean, why did it do it once? What the hell? It should have done it 100 times, but it did it once. Oh, because I do it once in every iteration, but this actually happens 100 times. Okay. What happened? This took 1,370 seconds, and this took 62 milliseconds. Sorry, not seconds. As you can see, just by putting stuff one line above, made the execution time way faster. So what was it? 1370. And this one, 62. Oops. So you can see a significant difference. And that's pretty much all I wanted to show for this lesson. Do you have any questions, guys? Any more questions? All right. So there was one more question I can answer fast. The question was by who was it? Anyway, someone asked about how do I know if I'm experienced with C#? Experienced enough, and the answer is: are you comfortable doing LNQ? Are you comfortable writing application from scratch without googling, without much googling? Do you know what you're doing? Do you feel confident with your choices? Can you use database fluently? Can you create a web service? Can you create a client? And if the answer to all those questions is yes, then you are an advanced C# developer, a junior no longer. Thanks, guys. Yeah, so you need to know MVC, you need to know advanced C# principles like LNQ, like generics, like events, delegates, lambda expressions, and so on. So only then you can call yourself advanced. And now it's time for Kahoot. Kahoot, hype. I really hope I didn't make mistakes in it. Okay. So let me quickly have a look at it just one more time. Be ready, I'll give it the link in a few minutes. New element. Mm-hmm. Mm-hmm. Okay. Glad that I looked at it again, because I see one problem. Give me a sec. Okay. Okay. Good. I can give it the link. Give you the link. Okay. Here is the number. So go here. Let's wait one more minute just in case, and we can start. All right, we can start. So first question, warm up, what is an array? Most people got it right. I believe the last person who didn't get it right just misclicked. Do arrays start at 1? Right. Next. Is it possible to change value of an array element? So 4 people answered it incorrectly as false. You cannot add elements to array. An array size is immutable, but array itself is not immutable. You can change element values in it. If you take an individual element value in an array, you can set it using index. Is it possible to add a new element to an existing array? It's not, because to add a new element, we need to create a new array with 1 extra size. And actually, I'm surprised and proud that you all got this correct, so it's really good. Next. Boot Ninja first, Nevin second, Roloff third. Nice. Which of the following is not a valid way of creating an array? Somebody is having doubts. 3, 2, 1. So people picked this and this. If you remember, this is called object initializer. And this is also called object initializer, and actually this is int as type is optional. You don't have to use it. But this one, you never need to supply the size of an int, of an array when you define it, when you declare its type. It wouldn't make sense otherwise. This is an array, and array is just with those square brackets. You give it a size in this place and not in this place, so that's a mistake. Let's see the leaders. Tombo number 1, Nevin second, Cabbage third. So which of the following is a valid way of getting count of array elements? Well done. Count is also used, but it's used differently with brackets, but it's not for array. It's likely for a different thing, and about that later. So, well done. Cabbage number 1, Nevin second, Tombo third. Count works, but not with the way it was written. What will happen if you access array element at index -1? Well done. Lesson learned. Next. Nevin number 1, Cabbage second, and Michael Fox third. What is a loop? Well done. Nevin first, Cabbage very close, Tombo third, and very close, Michael Fox. Which of the following will not iterate the array? Yes, so this one always iterates the whole elements. This one does also iterate all elements. This one does not, because it will stop at first at second condition. Actually, well, it will never stop. That's the point. It will always be negative, and it will be decremented every time, and yeah, out of range immediately. So it's bad for that reason. True or false? No, it cannot be. No column after those. Is it true that a do-while loop will always do at least one iteration? This D letter is out of place. So those who answered false, it will always do one even if an array is empty, because it will check all other things after, and in fact, array being empty or not is irrelevant, because it relies on other things. Next, I'll quickly double check. Which one of the following is the most suitable if I just want to stop loop execution? I just want to stop loop execution. Hurry up, there is too little time for this one. I forgot to increment it. Well done. If I want to stop loop execution, I need to break. Continue will skip to the next iteration, and return will not only stop loop execution, but it will also exit the function. And let's see the winners. Mihail Fox third, Tombo second, and the winner this time is Nevin. Congrats. PogChamp, hi, Nevin. PogChamp, Nevin, please in the chat. If the question had something like this in the end, then it might have been my bad, but just pay attention to the one that seems the most close to the actual answer. So yeah. Okay, great. Now it's time to give homework. So, homework time. Okay. Fetch the latest branch. Fetch the homework branch. Fetch this branch. All right. All right. So this is the homework. Let me format properly. Yeah, it's got. It's got. I'll post on Discord then. Let's go to Discord. Let's go to announcements, the homework, and let's paste it there. All right, so homework is to essentially implement different operations with array, sorting array with whatever algorithm you find on the internet, or come up with your own sort if you want to inverse the order, the elements, positions of array. So if it was 1, 2, 3, it needs to be 3 to 1. If it was 2, 1, 2, well, sorry, if it was 2, 1, 1, it needs to be 1, 1, 2. Remove first element from array, remove last element from array, remove element at a given position, and the same operations for insertion. And test for everything, you need to pass it. This time, no silly tests for checking what gets printed. It's all in black box. I will just check input and output and nothing more in between. So you have freedom to do it the way you want. The only constraint is that you will have to do it in the predefined functions, but it doesn't matter much as it is well named and you just need to fill it with the implementation details. So I can show you, so yeah. I can commit this now and I'll link all the things. But yes, that's it for this lesson. So thanks guys for watching and see you next time. Good night.